Strength assessment of concrete using marble waste and ceramic waste, a critical review. Abstract: in the current review study, it is seen that the waste marble is utilized broadly in cement rather than total and concrete. Subsequently, the point included limiting the hurtful impacts of waste marble on the climate. Besides, the impacts of waste marble on the strength of cement were explored. Reusing choices for squander marble were investigated in detail dependent on a survey of past examinations. The outcomes showed that the utilization of waste marble in cement in specific rates was sufficient to supplant the coarse/fine total, concrete, and admixture material, and that the subsequent cement displayed higher strength. Also, in the current investigation, common sense conditions were created to ascertain the compressive strength and parting rigidity in solid that contains squander marble. A genuinely solid match was gotten between the determined and estimated values for both compressive strength and parting rigidity. The logical estimation of the examination was shown through an exhibition that demonstrated that the utilization of waste marble in solid creation was advantageous and given helpful conditions to decide the compressive strength and parting elasticity of cement without experimentation. This survey additionally covers the supplanting of concrete with squander fired and the utilization of waste earthenware as total in solid creation. Based on the inspected considers, it was seen that as the measure of artistic waste powder utilized instead of fine total expands, its usefulness diminishes. Notwithstanding, this powder adds to the compressive strength of cement due to CaCO3 and SiO2 present in the compound structure of marble, while earthenware pieces utilized instead of coarse total add to the functionality and mechanical properties of cement. At the point when common standard sand is supplanted with fired residue at a proportion of 15e75%, the compressive strength increments by 20e26% while the parting rigidity increments by 10e15%. Nonetheless, coarse earthenware totals accomplished the best outcomes at a 100% substitution proportion. In addition, squander clay in coarse total structure improves the mechanical properties over the residue structure. Earthenware squander powder that is supplanted with concrete in amounts of 20% or more was resolved to affect the compressive strength and functionality of cement. Keywords: ceramic waste, marble waste, compressive strength, split tensile strength, flexural strength. Introduction. General. Concrete is the most widely used construction material in the world. Concrete is a kind of material which is mainly used to carry out various construction works. In all kind of construction works the need of concrete will be there. So therefore day by day the demand as well as the usage of the concrete had been increased from the past several years. Concrete can be used to build various kinds of structures such as dams, buildings, bridges, etc. In the preparation of concrete basically three major materials should be available, which are then mixed thoroughly either manually or mechanically. The basic three materials are cement or any other binding material, natural fine aggregate and natural coarse aggregate. With the help of these three materials concrete can be prepared. Marble waste powder. Marble powder or marble waste powder is defined as a special type of powder which is generally not available in nature in its natural form. It is generally derived during various cutting or devastating process from the natural marble, and the waste generated during this cutting as well as polishing process is in the form of powder, and this powder is called marble waste powder or marble waste powder. This marble is much finer as compared to the cement and can be used as a binding material and concrete as a partial replacement of cement. Properties of MWP. Marble squander powder was gotten as a loss from the marble business through the injuring, smashing, and cleaning of marble. Different properties of marble squander powder or marble squander powder are shown below. Table: Properties of marble powder. Details. Values. Uses of MWP. Marble has been usually used as a building material since the prehistoric times. Therefore, marble squander as a side effect is a significant material which requires sufficient ecological removal exertion. What's more, reusing waste without appropriate administration can bring about biological damages bigger than the assault itself. Marble dust is a side effect framed during the creation of marble. A lot of fine particles is gotten during the injuring cycle. The outcome is that about 25% of the remarkable marble mass is lost as residue. Lofting these misuse supplies to the surroundings openly can root ecological harms such as increase in the soil alkalinity, affects the plants, affects the human body, etc. Marble dust, a hard devastate matter obtained from the marble doling out, can be used moreover as a stuffing material in cement or fine aggregates while producing concrete. Marble waste powder can be used as an enhancer in concrete, so that potency of the concrete can be greater than before. The manufacture of low-cost and tougher concrete using this squander can help the civil engineer fraternity to ensure economy in the infrastructural project and redress the environmental degradation problem. Ceramic waste aggregate. Ceramic coarse aggregate is fundamentally gotten from the earthenware business, where immense measure of artistic waste is begun and is then unloaded in streams or different other unloading destinations. This waste is a lot of hurtful from the ecological perspective. Stoneware are routinely used in the creation of divider and floor tiles, squares and material tiles. Sanitary ceramics are obtained from ordinary resources which usually include kaolin, clay, potassium, and quartz. Building business as the end user of roughly all the ceramic supplies is well perched to resolve this ecological dilemma, which is partly its own. The use of squander products in concrete is not only inexpensive but also solves some of the waste dumping issues. Compressed ceramic aggregate can be used to make insubstantial concrete, without disturbing strength. The high utilization of raw materials by building sector results in constant lack of building resources and is associated with ecological damage. Properties of CWA. Ceramic aggregate was acquired from different building locales as a waste, during the cutting and setting of tiles. These clay tiles can be utilized in concrete as rate replacement of normal total. Different tests were performed on clay total and certain properties were resolved, which are demonstrated as follows. Table, properties of ceramic aggregate. Details. Value. Color. Mixed. Shape. Angular. Maximum size. 20 mm. Specific gravity. 2.62. Water absorption. 0.23%. Uses of CWA. The ceramic waste aggregate can be used easily as various public as well as private sector construction. Ceramic can be used by every construction industry so as to increase the strength and to decrease the construction cost as well. Ceramic waste aggregate is mainly used in the production of light waste aggregate concrete or recycled aggregate concrete. It also increases the strength and durable properties of the concrete. Literature review. Marble waste. Ashish DK, 2019. He uses marble powder as partial replacement of fine aggregate and uses two materials as partial replace CM3 and of cement. The two materials were metakaolin and silica fume. It was observed that the 15% replacement of marble powder was giving maximum durable properties, and beyond this percentage the strength was decreasing. Singh M, 2019. He replaced both cement as well as fine aggregate with marble powder at different percentages. He replaced cement at 10%, 20% and 30% with marble powder and replaced fine aggregate at 20% and 40% with marble powder. It was observed that the 15% replacement of cement was giving desired maximum strength. Esra Tugral T, 2019. In its study he replaced both cement and aggregate with marble waste. It was observed that the marble waste is good only up to some required content. After that, the strength parameters of concrete are decreasing adversely. It was also observed that the optimum percentage of replacement of marble powder as partial replacement of cement was 10%. Muhammad J. M., 2017. It was observed that the marble powder is neither fully an inert material nor fully a pozzolanic material. The results of compressive strength show that the maximum strength was observed at 10% to 20% replacement of cement with marble waste powder. Vidavi C., 2013. In this study marble powder was replaced by cement particles, and after that various tests were performed so to get the desired results. It was observed that the usage of marble powder decreases the cost of the concrete when replaced at different percentages. The 10% replacement of marble powder was giving the maximum results. South Rajan VM, 2013. In this research work the author replaced cement at different percentages with marble waste powder, which is approximately finer as compared to the size of cement. A phenomenal increase was observed in the compressive as well as tensile strength of concrete. Ceramic waste. Zara K., 2019. In this study the natural 20 mm coarse aggregate was replaced by ceramic coarse aggregate and totally 65 specimens are casted. Basically two major tests were performed, that are compressive strength test and flexural strength test. The test results shows that the compressive strength of concrete increased by 41% due to the addition of ceramic waste aggregate in the concrete. Siddiq S., 2018. In this study, he replaced fine aggregate with fine ceramic particles at different percentages. First the ceramic waste is converted into fine particles and then replaced at different percentages such as 20%, 40%, 60%, 80%, 100%. It was observed that the 40% at replacement was giving maximum results from strength point of view. Seeker M., 2017. In this study, he uses ceramic aggregate as partial replacement of coarse aggregate, and after this several tests were performed over it. The various tests performed were compressive strength test, split tensile strength test and ultrasonic pulse velocity test. From the various testy results it was observed that the maximum strength was observed at 40% replacement of coarse aggregate with ceramic aggregate. Paolo, 2017. In this investigation the clay total was utilized as a halfway substitution of coarse total at 0%, 5% and 10%. It was observed that the ceramic aggregate has lesser dead weight as compared to the normal natural coarse aggregate. So it can easily be used for the preparation of cost-effective concrete and lightweight concrete. Aruna D., 2016. In the research work the author replaced both coarse aggregate and fine aggregate with ceramic waste aggregate in aggregate form as well as fine particles respectively. The M20 grade of concrete was used for the research work and cement was replaced by fly ash. It was observed that the strength parameters of concrete with the replacement of cement and coarse aggregate increases at lower percentages and tends to decrease after further replacement. Conclusions. The examination included researching the reusing of marble waste and clay squander as total and concrete substitute in cycles including SCC and blacktop creation. Its impact on the compressive strength and parting elasticity of related concrete sorts in detail are given underneath. Approximately 15% monetary benefit can be picked up by reusing waste marble. The outcomes recommended that the use of waste marble in the creation of cement is profitable as far as getting modest and strong cement and tackling environmental issues. To add to both the marble business and public economy, it is important to reuse squander marble in related zones, and subsequently it is important to use endeavors to create reusing applications. Along these lines, it is viewed as that this possibly adds to natural and human well-being. The impact of waste marble use in cement on the strength of the solid was researched. The outcomes recommended that the utilization of waste marble powder as coarse/fine total, concrete, and other waste material substitute improved the strength of the solid. The outcomes showed that the ideal substitution rate was 10% while utilizing waste marble powder as a substitute for concrete in cement. In this manner, the concrete with ideal solid strength was gotten by utilizing 10% waste marble substitution for concrete. Replacing concrete with 5 to 10% artistic waste powder improves the mechanical properties of the solid, while lessening the CO2 discharges of concrete creation by 12%. Enhancing up to 75% of the concrete load with clay squander powder as a filler material improves the compressive strength by 42% and the parting rigidity by 42%. In coarse total structure, artistic waste substitution applies more sure effects as the W/C proportion decreases. In fine total structure, clay squander powder accomplished the best outcomes at substitution proportions of 50 and 75%. In these cases, the compressive and parting rigidities were expanded by 20 to 26 and 10 to 15%, individually. In coarse total structure, Fired waste powder builds the compressive strength by 20 to 70% and the parting rigidity by 50 to 80%. Utilized as filler material, artistic waste powder improves the compressive and parting elastic qualities of cement by 42 and 41%, individually. To improve the monetary recuperation of squanders, solid specialists have proposed subbing an extent of cement with clay squander powder and slurries of result/squanders from the waste lakes of work environments and plants. Different examinations have explored the recuperation of feudal clay squander powder by pounding them into coarse totals that can be subbed into concrete. When subbed at suitable proportions, artistic applies no unfriendly consequences for solid quality except for may improve the mechanical details. As indicated by the assessed examines, the utilization of clay in solid creation benefits the economy and lessens natural contamination. Totals of fired waste give off an impression of being particularly appropriate for solid creation in prepared blended solid plants.